4.5 billion years ago, while Earth was still a molten hellscape, life appeared in just 600 million years. Scientists describe this as impossibly rapid. We think that life emerged from primordial soup, progressed slowly, and eventually formed humans. But what if we had it backwards? What if life came down from space, carrying the genetic blueprints of civilizations that existed billions of years before the Earth was founded? If you're ready to rethink everything you know about human beginnings, click the like button and subscribe. We're about to unearth evidence that we might be aliens. Prepare yourselves. We begin. Consider trying to create a functional smartphone by shaking a package of electronic components for 600 million years. The arithmetic driving life's birth on Earth defies all probabilities. When our planet finally cooled enough to accommodate liquid water, something remarkable occurred. In what scientists call a cosmic blink, sophisticated molecules began arranging themselves into self-replicating systems. These weren't just simple carbon-hydrogen chains. We're talking about sophisticated biological devices that can reproduce themselves with incredible precision. Think about the timeline. Earth came into being 4.5 billion years ago. For the first 800 million years, our planet was essentially a big lava lamp, regularly pummeled by asteroids and comets. The surface temperature exceeded 2,000 degrees Fahrenheit. Nothing could survive. However, by 3.8 billion years ago, we find evidence of complex microbial life thriving in the fossil record, implying that evolution took only 600 million years to progress from barren rock to live organism. Charles Darwin referred to its quick development as the warm little pond problem. He knew that natural selection required a long time to develop even the most basic life forms, but life appeared practically instantly on Earth after conditions became favorable. Consider the level of complexity we are working with. Even the most basic microbe comprises over 4 million distinct elements that work in perfect harmony. DNA, RNA, proteins, cell membranes, and energy-generating processes. It's like discovering a completely built Boeing 747 in a junkyard. Yesterday, there were simply raw materials. Modern scientists have attempted to recreate these conditions in laboratories. They've combined all of the necessary chemicals, applied electrical charges to imitate lightning, and weighed the results. A few simple amino acids, the building blocks of proteins, are not even close to a living cell. The gap between chemistry and biology is still unknown today. As it was in Darwin's time, however, there's another explanation that makes the timing more logical. What if life on Earth did not start from scratch? What if it came here already assembled, already tested, already proved to function? Imagine life as a cosmic bequest passed down from civilizations that solved the biological challenge billions of years before our solar system began. This isn't science fiction anymore. NASA discovered chemical substances throughout the galaxy. The European Space Agency discovered complex compounds in interstellar clouds. The fundamental components of life are not unusual cosmic accidents. They are wherever we look. The panspermia hypothesis. According to this theory, life spreads throughout the universe like seeds on the wind, with some seeds landing on appropriate planets and taking root while others drift through space for millions of years, waiting for the proper conditions. Earth was not the cradle of life. It was simply another garden where cosmic seeds had found rich ground. If this idea is correct, then every living thing on our planet, including ourselves, possesses the genetic memory of civilizations that lived long before Earth was even a gleam in a star nursery. However, the proof goes much beyond simple mathematical likelihood contained inside the boulders that regularly shower down on our globe. Scientists have discovered something that calls into question all of our assumptions about the origins of life. Every day, Earth is bombarded by 100 tons of cosmic debris. The majority of these cosmic visitors burn up in our atmosphere, resulting in the shooting stars we desire for. But others survived the journey and crashed into our world as meteorites. For almost a century, scientists have been splitting apart these space rocks in search of minerals and metals. Instead, they found something even more astonishing. When a 4.5 billion-year-old meteorite blasted into Australia in 1969, it changed everything. Researchers discovered something impossible within amino acids, not just any amino acids, but 74 different varieties, including many that do not occur naturally on Earth. These were not contaminants from our planet. The chemical signatures confirmed their formation. Deep space. Think of amino acids as biological Lego blocks. Every protein in your body, from hemoglobin, which transports oxygen in your blood, to the enzymes that digest your food, is made up of these important components. Finding them in a meteorite was like finding a construction kit for life drifting through space. But the merchant and meteorite weren't alone. The Allende meteorite, which landed in Mexico, contained much more complex chemical molecules. Scientists discovered nucleotide bases. The Murray meteorite revealed sugar molecules that comprise the backbone of genetic material, which correspond to the letters that spell out genetic coding in DNA and RNA. The Carbon Hill meteorite included lipids, which are the building components of cell membranes. This is where things become truly mind-bending. Some of these meteorites are older than our solar system. They evolved in star nurseries billions of years before Earth, transporting biological cargo over vast distances and temporal gaps. It's like getting a message in a bottle from civilizations that existed and died before our sun was born. Recent analysis has something more surprising. Some meteorites include microscopic formations that resemble ancient microbes. These are not random mineral formations. They have the characteristic shapes, sizes, and internal structures of live cells. When NASA scientists claim to have discovered signs of ancient Martian life on the ALH84001 meteorite, it generated significant discussion. The ramifications are startling, even as they are preserved within its granite structure. If meteorites conveyed organic molecules throughout the early solar system on a regular basis, the building ingredients of life were supplied to planets like cosmic Amazon. Earth, Mars, Venus, and the moons of Jupiter and Saturn were all getting biological cargo from outer space. This delivery mechanism is still operational today. When you see a meteor, take a shower. You're watching potential life seeds rain down on our planet, along with other meteors, Geminids, and Leonids. Each streak of light indicates an organic substance being deposited in our environment. Some scientists now assume that during Earth's early bombardment period, asteroids and comets were regularly bombarded. Our planet was more than simply a destructive force. It was the universe's method of cultivating a garden. Every collision produced fresh genetic material, new biological possibilities and evolutionary roots. However, if meteorites can transport life's building blocks across space, the next question becomes much more astonishing. Can biological beings survive the journey? The answer rests with our planet's most extreme animals. Organisms are extremely resilient. They appear to be built for interstellar travel. Earth is located in the most ideal location possible, 93 million miles away from a properly sized star. We call it the Goldilocks zone. Not too hot, not too cold, just the correct temperature for liquid water to exist. Moving us 5% closer to the sun transforms us become Venus, with sufficiently heated surface temperatures. To melt lead, we move 10% farther away and turn into Mars. The mathematical precision of a frozen desert where water only exists in the form of ice and vapor is amazing. Our planet's orbit fluctuates by less than 2% per year. Our moon is precisely the perfect size to regulate our axial tilt, preventing wild climate extremes would render sophisticated life impossible. Our atmosphere is composed of 78% nitrogen and 21% oxygen, making it highly chemically reactive. It should have burned up billions of years ago. However, this delicate balance has stayed constant for billions of years. The chances of something occurring by chance are so slim that scientists struggle to represent them quantitatively. It's equivalent to flipping a coin and getting heads 10,000 times in a row. But here's what causes the Goldilocks dilemma. Stranger Earth was not always like this. This ideal 4 billion years ago, our sun was 25% darker than it is now. According to all estimations, our planet should have been a frozen snowball, incapable of supporting life. Scientists call this the faint young sun paradox. Despite this, life not only survived, but thrived throughout this allegedly impossible time. The geological record contains unambiguous evidence of liquid oceans and complex microbiological ecosystems. Something was keeping the ground warm when it should have been cold, creating conditions that permitted life to thrive and spread. Traditional ideas fail to explain this. Some scientists propose enormous volcanic activity produced a greenhouse effect. Others propose that the early Earth had a considerably denser atmosphere. However, their explanations rely on a succession of odd coincidences that strain credulity. The panspermia hypothesis provides a distinct perspective. What if the flawless conditions on Earth are the result of engineering rather than accidents? Imagine advanced civilizations. Faced with the extinction of their own worlds, they did not just distribute genetic material at random. What if they purposefully chose target planets and modified them to be habitable? Consider the precision required. You would need to change the ambient composition, orbital mechanics, magnetic field intensity, and planetary rotation. You'd have to account for stellar evolution, ensuring that your chosen planet remained livable as its star aged and brighter. This level of terraforming would necessitate knowledge and technology well beyond our current capabilities. Evidence for this type of deliberate change may be hidden in plain sight. Consider Earth's extremely huge moon, for example. Could be the consequence of a deliberate collision intended to generate tidal forces and steady our planet's rotation. Our magnetic field, created by a liquid iron core, protects us from lethal sun radiation in a way that appears almost too convenient. Even our position in the galaxy looks to be optimal for life. Astronomers refer to our orbit as the galactic habitable zone, which is far enough away from the galactic center to avoid harmful radiation, but close enough to benefit from the heavy metals released by dying stars. If Earth was purposefully designed as a biological laboratory, the following question becomes critical. What kinds of species could make the trek from their dying worlds to our neatly planned one? Scientists discovered microorganisms flourishing inside rocks deep in the Atma Desert, where it has not rained in over 400 years. Endoliths are organisms that live in environments that would kill practically any other type of life on Earth. Despite having no water, oxygen, organic nutrition, or radiation levels that would kill humans, they not only live, but multiply, forming extensive ecosystems in what looks to be solid stone. This discovery prompted researchers to ask an unexpected question. If life can exist in the world's most severe conditions, what about the ultimate extreme environment, outer space itself? The answer came from experiments conducted aboard the International Space Station. Scientists subject bacterium samples to the vacuum of space, where temperatures range from 250 degrees below zero to 250 degrees above. There is no air pressure, no protection against cosmic radiation, no nourishment, and no water. These conditions would kill a person in seconds. The germs not only survived, but are still reproducing. Aucus radians, also known as cones in the bacterium, can resist radiation doses 3,000 times higher than those that would kill a human. When its DNA is torn by cosmic rays, it can survive in complete isolation for years. It just rebuilds itself through internal repair mechanisms that scientists are still working to understand. Tardigrades, microscopic organisms that resemble eight-legged bears, are even more remarkable. They can fully shut down their metabolism, resulting in a state known as cryptobiosis, in which they are neither alive nor dead. In this form, they can withstand temperatures as low as 458 degrees Fahrenheit, only a few degrees above absolute zero. They can withstand 6 times more pressure than the deepest ocean depths. They can live without food or water for more than 30 years. But now comes the truly mind-bending phase. When tardigrades were subjected to space vacuum for 10 days, 70% of them survived. When they returned to normal settings, they resumed eating, reproducing, and acting as if nothing had happened. These are not isolated examples. Bacteria have been discovered to live in nuclear reactors, pools of concentrated acid, boiling hot springs, and millions of years-old Antarctic ice. Each discovery contributes to our understanding of life's remarkable tenacity and adaptability. If organisms this tough exist naturally on Earth, imagine what kinds of life forms might exist on planets with even harsher conditions. On planets orbiting dying stars, planets with thick toxic atmospheres, moons covered in radiation, and bombarded ice, life may not only survive, but thrive. This fundamentally alters the concept of interplanetary travel for biological organisms. We used to believe that life was fragile and required optimal conditions to survive, including brief travels into space. We now know that some Earth creatures may be able to endure travels lasting thousands, if not millions, of years. The ramifications are startling. If bacteria and tardigrades can live in space, they may be traveling on asteroids and comets right now. Every meteorite impact, like a biological stowaway traveling between star systems, might be transporting not just organic chemicals, but actual life passengers from faraway planets. Panspermia, however, requires more than just survival. When these cosmic travelers arrive, they will need to find optimal growing circumstances. The topic is whether the Earth's fossil record contains evidence of rapid biological arrivals that cannot be explained by progressive evolution. Charles Darwin saw it as the most significant challenge to his theory of evolution. The fossil record, which should show progressive transitions between species, reveals something far more mysterious. Complex living forms emerge quickly and completely formed, with no obvious ancestral lineages. It's like discovering modern smartphones under archaeological layers with no traces of previous communication gadgets. Take the Cambrian explosion 540 million years ago, which lasted 3 billion years. The Earth was populated nearly entirely by rudimentary single-celled creatures and basic multicellular species. Then, in a geological instance lasting only 25 million years, nearly every major animal group arrived in the fossil record at the same time. We're talking about organisms with complex eyes, sophisticated neurological systems, exquisite shells, and clever hunting techniques. Trilobites appeared with compound eyes including more than 15,000 separate lenses. Animal Ocarus is more advanced than the majority of modern insects. A 6-foot-long predator appeared, with flexible arms and intricate mouthpieces specialized to process prey. Where are their ancestors? Where are the transitional forms that demonstrate the progressive evolution of certain features? According to traditional evolutionary theory, we should find millions of intermediate fossils, showing the step-by-step transition from simple to sophisticated. Instead, we find gaps so vast that paleontologists have named them the Cambrian Gap. But the Cambrian explosion is not exceptional. Similar unexpected appearances occur throughout the fossil record. Birds arise in the Jurassic period without distinct reptilian predecessors, demonstrating the gradual evolution of flight. Flowering plants originate in the Cretaceous period. Without evident antecedents, mammals swiftly evolve following the dinosaur extinction, filling ecological niches at breakneck speed. Even more puzzling, these sudden appearances frequently correspond with asteroid crashes and cosmic bombardment events. The Permian-Triassic extinction, the largest mass extinction in Earth's history, was followed by an explosion of new life forms known as an asteroid impact. That killed the dinosaurs and resulted in mammalian diversification. Each cataclysmic event appears to unleash waves of biological creativity. Modern genetics adds another dimension to the riddle. When scientists compare DNA sequences from many species, they discover that many critical genetic breakthroughs arrive unexpectedly in the evolutionary history, such as the genes responsible for complex eyes, are very similar across drastically different animal groups, indicating that they did not evolve separately, but were inherited from a common source. Photosynthesis, for example, exhibits this pattern of abrupt emergence. The mechanism of converting sunlight into energy appears completely developed in the fossil record. In the absence of a defined evolutionary process, the complex machinery required for DNA replication and protein synthesis arises without visible transitional stages. Traditional evolutionary theory explains these gaps as artifacts of poor fossil preservation's soft-bodied species, they believe, do not fossilize well, resulting in an incomplete record. However, this hypothesis struggles to account for the mathematical improbability of so many complex systems arising at the same time. The panspermia theory provides an alternate explanation. What if these abrupt appearances are biological colonization events? What if cosmic seeding delivers genetic blueprints from civilizations that have already overcome these evolutionary challenges? If Earth has been receiving biological packages from space for billions of years, we could expect to uncover proof that this delivery mechanism is still active now. The trick is to understand where to seek and what cosmic settings may be producing the building elements of life right now. Between the stars are chilly areas where atoms rarely move. Something unusual is occurring. Vast clouds of cosmic dust spanning light years of space are spontaneously forming complex chemical compounds. These are not random chemical processes. Radio telescopes have found over 200 different chemical molecules floating in interstellar space, including many of the basic building blocks of life. The Eagle Nebula, 7,000 light-years away, contains enough biological material to seed millions of planets. The Orion Nebula creates trillions of alcohol molecules, as well as sugars, amino acids, and other complicated compounds that scientists are still trying to define. These celestial nurseries aren't simply creating new stars and planets, they're also producing biological chemistry on an industrial scale. How is this feasible in a vacuum like space? The key is hidden in tiny dust grains, each smaller than a cigarette smoke particle. These minuscule factories provide surfaces for atoms to meet and connect, shielded from the severe radiation that would typically break molecules apart over millions of years. Simple hydrogen and carbon atoms combine to create increasingly complex structures. Think about each dust grain as a cosmic laboratory. Hydrogen atoms adhere to the surface and slowly accumulate. When ultraviolet light from nearby stars strikes these grains, it provides just enough energy to trigger chemical reactions while preserving the products. The process is analogous to slow cooking on a cosmic scale, with patience and precise circumstances producing molecular complexity that shouldn't exist in outer space. Recent investigations by the James Webb Space Telescope have shown something much more remarkable. Some interstellar clouds include chemical structures that are as complicated as the chemistry found within living cells. Long-chain hydrocarbons, ringed organic molecules, and even rudimentary membrane-like structures have been observed floating in locations with temperatures 400 degrees below zero. These results significantly alter our understanding of the distribution of life's building materials. Rather than organic chemistry being rare and limited to planetary surfaces, we now know that it occurs continually across the galaxy. Every star-forming region is also a molecule-forming region, producing biological ingredients that are eventually incorporated into new solar systems. When these dust clouds eventually condense to become stars and planets, they retain their organic content. Instead, all of those complicated chemicals are collected into asteroids, comets, and planetary atmospheres. It's as if the cosmos has been conducting a three-dimensional printing operation for billions of years, producing biological components and dispersing them throughout the galaxy. The magnitude is mind-boggling. Our Milky Way galaxy includes billions of these molecular factories, each of which produces organic compounds with the mass of thousands of Earths. The rate of production implies that every solar system, including ours, emerged from material rich in life precursors. This cosmic chemistry set explains why organic chemicals are discovered in meteorites from the early stages of solar system development. These materials did not arrive on Earth by happenstance. It was an unavoidable consequence of our cosmic environment, in which the building blocks of life are as abundant as hydrogen and helium. However, finding organic substances in space is only the first step. The actual challenge remains. Is there direct proof of biological activity reaching Earth from these star laboratories? On July 20, 1976, something remarkable occurred in the history of human exploration. The Viking 1 lander landed on the Martian surface and immediately began conducting experiments to identify indications of life. What happens next? Initiated a scientific debate. That continues to this day and may have offered the first direct proof of panspermia in action. The labeled release experiment was beautifully straightforward. The Landis scooped up Martian dirt and combined it with a nutritional solution containing radioactive carbon. The logic was obvious. If microorganisms existed in the soil, they would absorb nutrients while emitting radioactive carbon dioxide gas. Sensitive detectors could measure. The results were quick and striking. Within hours, the detectors picked up a sharp increase in radioactive gas production. The pattern matched what you'd anticipate from biological metabolism. Living organisms were apparently consuming the nutrition and exhaling radioactive carbon dioxide. The experiment's designer, Dr. Gilbert Levin, was confident they had discovered life on Mars. But NASA, stay skeptical. They conducted additional testing, including control studies in which soil samples were heated to temperatures that should have killed any bacteria, and the heated samples produced no gas. It appeared to confirm that the original results were the product of biological activity. However, additional trials on the same trip yielded inconsistent results. The gas chromatograph, which is designed to detect organic molecules, detected no carbon-based chemicals in Martian soil. How could living beings exist without organic chemistry to support them? For decades, the scientific community disregarded the Viking findings as chemical rather than biological Mars. They contended that it was too cold, dry, and radioactive to host life. The gas production must have resulted from undiscovered chemical interactions in the alien soil. However, this explanation was never completely satisfactory. Critics. Viking observed patterns that were surprisingly comparable to biological signals. The fast initial response followed by steady decline mirrored the behavior of the Earth. Microorganisms were introduced to novel nutrition sources. Chemical reactions usually produce a constant, predictable gas. This means that the genetic code has built-in redundancy, much like a language engineered to withstand transmission failures. Mathematical precision is amazing. The genetic code has been streamlined to prevent mutation-related damage. If cosmic radiation alters a single letter in a genetic word, the redundancy assures that the subsequent protein remains functional. It appears that this technology was specifically engineered to withstand the severe conditions of interstellar space. But here's what scientists are concerned about. This level of efficiency would not exist if the genetic code evolved randomly on Earth. Computer simulations reveal that there are millions of different genetic codes, the majority of which would be completely suitable for life on a stable planet. Nonetheless, out of all these options, life on Earth employs the one code that is virtually ideal for surviving cosmic radiation. The possibility of this occurring by chance is around 1 in a million. It's like randomly creating a computer password and realizing it's perfectly tuned for security. By someone who understood advanced cryptography. Recent genomic study has shown even odd patterns. Human scientists did not discover mathematical principles that govern the arrangement of DNA letters until the 20th century. The genetic code contains evidence of error-correcting systems, redundancy systems, and information compression techniques that rival the most advanced computer programming. Some researchers have discovered what they call wow signals concealed in DNA patterns. These mathematical patterns are so accurate and unusual that they appear to be deliberately embedded messages. The Fibonacci sequence, prime numbers, and other mathematical constants appear to be woven into the very structure of DNA itself. Consider what happens if these patterns are purposeful. Then the genetic code is more than merely a byproduct of Earth's evolution. It's a design system established by intelligences who knew biology and mathematics at levels that we're only now beginning to understand. The timing adds an extra dimension of mystery. The universal genetic code appears to have evolved very early in Earth's history, during a time when our planet was heavily pummeled by asteroids and comets. This is precisely when we would expect cosmic seeding to have the biggest effect on terrestrial biodiversity. Even more intriguing, the genetic information appears to have been compacted for efficient transmission, similar to what a digital file optimized for downloading DNA contains. The highest quantity of information in the smallest amount of space indicates that it was developed for long-distance space travel, where every bit of information must withstand radiation, damage, and thermal extremes. The fact that this code is universal throughout all species on Earth supports panspermia. If life evolved separately from numerous seeding episodes, we could expect to observe distinct genetic languages for various lineages. Instead, every organism utilizes the same system indicated a single source of information that was distributed internationally. If the genetic code contains signs of cosmic engineering, we can expect to uncover similar evidence of extraterrestrial influence in the most unlikely areas. Sometimes the most convincing evidence comes from places where we least expect to find life. Europa, hidden beneath 15 miles of thick ice, contains an ocean twice the size of all of Earth's oceans combined. Jupiter's fourth largest moon should not exist in any form that might sustain life. At 500 million kilometers from the Sun, surface temperatures drop to 260 degrees Fahrenheit. Solar radiation is 25 times weaker than what reaches the Earth. By all traditional standards, Europa should be a dead ice ball. However, something amazing is occurring beneath the frozen surface. Jupiter's immense pull exerts gravitational pressures on Europa's rocky core, generating enough heat to sustain liquid water for billions of years. This underground ocean contains more water than all of our planet's rivers, lakes, and seas combined, as well as liquid water. There could be life. A recent investigation of Europa's sparse atmosphere revealed water vapor plumes erupting from the surface and flying hundreds of miles into space. These geysers provide a direct view of the secret ocean below. When the Hubble Space Telescope investigated the chemical makeup of these plumes, it discovered something remarkable. The water signature is almost identical to that of the Earth's seas. The similarity extends beyond chemical isotope ratios, which act as fingerprints for diverse water sources, implying that Europa's ocean and Earth's seas may have a shared origin. This is difficult to explain if both worlds evolved separately from local elements in their own parts of the solar system, but Europa is linked to Earth. Might go far deeper than just water. The gravitational dynamics that maintain Europa's ocean liquid generate tremendous currents and chemical mixing, which may support complex ecosystems. Volcanic vents on the ocean floor, like the hydrothermal systems that support life in Earth's deepest seas, could produce energy. For biological activities, the most exciting hypothesis is that Europa's ocean is more than just theoretically livable. It might be deliberately exporting life to other planets. Every time those gigantic geysers erupt, they release water, dissolved minerals, and maybe biological material into space. Some of this material escapes Europa's weak gravity and reaches the larger solar system. Jupiter's tremendous magnetic field may accelerate these particles to incredible speeds, propelling them into the inner solar system, where Earth orbits. Over billions of years, this process could have carried innumerable biological bundles from Europa's secret biosphere to our planet's surface. The timing is ideal for early Earth. During the late heavy bombardment period 4 billion years ago, the solar system was chaotic enough to allow substantial material interchange between the world's asteroids and comets. Material is regularly transported from the outer solar system to the inner planets. Europa's, the ocean, which was already developed and potentially teeming with life, could have been seeding the globe throughout this critical period. This scenario answers various questions about early life on Earth. It makes natural that complex cellular systems emerge quickly. Biochemical processes are optimized for radiation survival, and the genetic code is universal. If life arrived here already tested and honed in Europa's old ocean, modern space probes are avidly investigating this theory. The planned Europa Clipper mission will examine the water plumes in unparalleled detail, looking for chemical molecules and possibly direct evidence of biological activity. If Europa is linked to Earth's biological past, it raises important questions regarding the nature of big evolutionary leaps in our planet's fossil record. 66 million years ago, a 6-mile-wide asteroid collided with Earth. The massive hit, which had the force of 10 billion atomic bombs, should have ended sophisticated life on our planet. The explosion melted rock, causing global tsunamis and releasing a massive amount of debris into the atmosphere. The sunshine was obscured for months. 3/4 of all species became extinct, including the dinosaurs, which had dominated the Earth for 160 million years. However, something unexpected occurred in the aftermath of this cosmic calamity. Instead of a long, gradual comeback, life burst into more diverse and complex forms than ever before, including mammals. Previously, little organisms living in the shadows of dinosaurs rapidly evolved into thousands of new species, and flowering plants thrived. New ecological niches were filled with incredible rapidity. This tendency is not limited to the Chicxulub impact throughout Earth's history. Major asteroid strikes have resulted in amazing biological innovation. The Permian Trias extinction, caused by immense volcanic activity and possibly cosmic impacts, was followed by the emergence of archos, the ancestors of dinosaurs and crocodiles. The late Ordovician extinction was preceded by an increase of marine biodiversity. The association is so strong that scientists have begun mapping impact craters against the fossil record. What they discovered defies traditional wisdom about evolution and extinction, rather than simply killing life. Cosmic impacts appear to provide new biological possibilities. Consider the mechanics of a large impact. The explosion does not simply kill organisms. It also produces conditions conducive to the survival and development of cosmic hitchhikers. Massive heat and pressure can result in hydrothermal systems that last for thousands of years. These settings, akin to the deep marine vents where life may have first appeared on Earth, could be ideal incubators for extraterrestrial microorganisms. The Raiderford impact structure in South Africa, which is 2 billion years old and 190 miles across, reveals geological evidence of long-lived hydrothermal activity. Rock samples from the crater include peculiar mineral structures and chemical traces, indicating that biological processes continued for centuries after the impact. Even more intriguing, some impact sites, such as the Sudbury impact in Canada, reveal evidence of fast organic compound production immediately following the crash. Organic carbon deposits from 1.85 billion years ago originated quickly after the impact event. These aren't simply random chemical processes. The molecular patterns point to structured biological activities. Recent computer simulations show that asteroid impacts can protect biological material during atmospheric entry. While surface rocks are burned to thousands of degrees, the core of big meteorites can stay relatively cool. Microorganisms lodged deep into oncoming asteroids may survive the journey and find themselves in settings constructed specifically for the impact event. This creates an ideal biological delivery method. Cosmic influences disrupt existing ecosystems while also offering evolutionary possibilities and delivering new genetic material capable of capitalizing on those opportunities. It's like clearing land and sowing seeds in the same operation. The evidence implies that Earth's evolutionary leaps are not only the result of random mutation and natural selection. They could be the product of regular biological resupply trips from space. Each one introduces fresh possibilities for life on our planet. But if cosmic collisions frequently bring life beings to Earth, we could expect to see species that appear to be designed specifically for survival on the journey between worlds. Under a microscope, tardigrades resemble little 8-legged bears walking around a miniature terrain. These minuscule organisms, which are smaller than a grain of salt, can be found anywhere on Earth. They inhabit moss, lichen soil, and water from the Arctic to the equator. What genuinely distinguishes tardigrades is not their habitat, but their ability to survive. When conditions become adverse, tardigrades enter a state known as cryptobiosis. Essentially, one becomes neither alive nor dead. Their metabolism decreases to 0.01% of normal levels. They lose 99% of their body water and curl into an unbreakable barrel known as ton. In this stage, they can withstand conditions that would destroy practically any other form of life on Earth. Temperature extremes that would instantaneously kill humans have no effect on tardigrades. They have withstood exposure to -458 degrees Fahrenheit, which is only a few degrees above absolute zero. They have also withstood temperatures of 300 degrees Fahrenheit. They can withstand pressure 6 times that of the deepest ocean tunnels, as well as radiation levels 6,000 times higher than those that would kill humans. Tardigrades are the only animals capable to surviving in space. When European Space Agency researchers subjected tardigrades to extreme temperatures outside the International Space Station for 10 days, 70% of them survived. When they returned to normal conditions, they had survived zero air pressure, cosmic radiation, and temperature changes that would have destroyed most known materials. This robustness appears to have been designed specifically for interplanetary flight. Tardigrades can stay in cryptobiosis for decades, possibly long enough to travel between neighboring star systems. Their ability to repair radiation-damaged DNA surpasses that of human technology. When cosmic rays shred their genetic material, tardigrades simply reconstruct it through molecular mechanisms. Scientists are still attempting to figure it out, but here's what makes the tardigrade riddle even odd. These survival talents are entirely superfluous for their typical earthly existence. Tardigrades normally live in mild temperate areas where temperatures rarely surpass 100 degrees Fahrenheit and radiation levels are low. Why would evolution evolve such great survival capacities for species that rarely face harsh conditions? Traditional evolutionary theory holds that traits evolve in response to environmental influences. However, tardigrades appear to be well equipped for settings far more hazardous than those seen on Earth. It's like discovering deep-sea diving equipment on animals living in shallow ponds. A new DNA research has found another perplexing aspect. In tardigrade biology, their DNA has genetic sequences that do not correspond to any other Earth creatures. Approximately 20% of tardigrade genes appear to have been acquired by horizontal gene transfer, albeit from unknown origins. This genetic material appears to be intentionally engineered. Some scientists now believe that tardigrades are living fossils from Earth's early biosphere, retaining survival qualities from when our planet was periodically hit by asteroids and cosmic radiation. Others suggest a more extreme interpretation. Tardigrades may be descendants of organisms that landed on Earth from space. The tardigrade enigma, which includes genetic adaptations gained during interstellar voyages, extends beyond individual survival to their potential role as carriers of other life forms. These minuscule passengers frequently host bacteria, viruses, and other microbes, forming biological cargo ships capable of transporting vast ecosystems across space. If tardigrades can withstand interplanetary travel, what about the cosmic delivery vehicles that may have transported them here in the first place? Every 76 years, Halley's Comet comes to our inner solar system with a payload worth more than any treasure on Earth. As this ancient wanderer approaches the sun, solar radiation begins to vaporize its frozen surface, resulting in the amazing narrative that has captivated humans for generations. Thousands of years have passed, but something astonishing remains concealed within that dazzling display. Complex chemical molecules, amino acids, and possibly even primitive life forms that have been kept in deep freeze for billions of years. Comets are time capsules from the beginnings of our solar system. They developed in the Kuiper and AUT cloud areas, so far away that they contain original ingredients from when the planet originally consolidated. Unlike asteroids, which have been heated and altered by their closeness to the sun, comets contain pristine traces of primordial chemistry. When the European Space Agency's Rosetta mission eventually made contact with Comet 67P in 2014, the revelations transformed our knowledge of these cosmic icebergs. The comet's nucleus includes 16 different amino acids, including glycine, the most basic building block of proteins. It contained complex organic molecules such as FIDE, which plays an important function in the synthesis of nucleotide bases. These are the building blocks of DNA and RNA. But Rosetta discovered something even more remarkable. The comet included organic molecules arranged in patterns resembling primitive cell membranes. These were not random chemical formations, but rather ordered molecular groupings that could perhaps function as containers for biological activity. The ramifications are startling if comets contain pre-biological structures. They are not simply giving raw ingredients for life. They're sending half-assembled biological kits that could hasten evolution on any planet they come upon. Consider the size of the delivery system. There are trillions of comets in our solar system, only in the out cloud. Throughout cosmic history, gravitational perturbations have sent these icy emissaries hurtling into the inner planets. Earth has been pummeled by comets for more than 4 billion years. Each impact sends masses of organic chemicals right to the planet's surface. The timing of major comet showers corresponds significantly with eras of fast biological evolution on Earth. The late strong bombardment 4 billion years ago coincided with the appearance of the first complex cells. Periodic comet storms have occurred throughout geological history, coinciding with evolutionary leaps that paleontologists find difficult to explain using slow processes alone. Modern examination of comet dust obtained by NASA's Stardust mission shows that these cosmic wanderers have isotopic fingerprints similar to life on Earth. The carbon, nitrogen, and sulfur ratios observed in comet samples are consistent with those seen in terrestrial species. Even more intriguing, some comets show evidence of internal liquid water during their long journeys through space, and radioactive decay within comet nuclei can create warm zones where chemical evolution may continue. During the millions of years between solar system visits, these wandering laboratories could be conducting biological experiments. If comets act as biological cargo ships as they move between star systems, their significance in panspermia goes far beyond our solar system. Comets are periodically ejected from planetary systems as a result of gravitational interaction with passing stars, sending them on intergalactic trips that might take millions of years. Some of these cosmic exiles are eventually grabbed by other star systems, who transport their biological payloads to other worlds. This interstellar comet exchange could help explain one of contemporary astronomy's most baffling mysteries. Why haven't we discovered evident indicators of alien civilizations despite the universe's age? In 1950, physicist Enrico Fermi posed an issue that continues to haunt scientists today. Where is everyone? The Fermi paradox reveals a worrisome paradox. Our galaxy has more than 400 billion stars, many of which have planetary systems capable of supporting life. The universe is 13.8 billion years old, allowing plenty of time for civilizations to form and expand throughout the galaxy. Despite decades of investigation, we discovered no conclusive evidence of extraterrestrial intelligence. Traditional explanations for the quiet are very disconcerting. Perhaps alien civilizations kill themselves before reaching interstellar distances. Perhaps intellect is so scarce that we are actually alone in a huge, empty universe. Some scientists argue that hostile alien entities purposefully inhibit the formation of new civilizations, using force to maintain galactic silence. However, the panspermia theory proposes a radically different interpretation. We are not seeking for aliens, we are the aliens. Consider this scenario. Billions of years ago, when our galaxy was young and chaotic, advanced civilizations faced the eventual demise of their star systems. Instead of accepting extinction, they devised the ultimate survival strategy: cosmic reproduction. They encoded their biological legacy into minuscule passengers capable of surviving interplanetary trips for millions of years. These ancient civilizations did not simply launch random genetic material into space. They meticulously built self-replicating systems that were ideal for long-distance travel and speedy colonization of compatible worlds, known as the Universal Genetic Code. The advanced error correction and radiation resistance were not the result of random evolution. It was created by intelligent beings who knew both biology and cosmic environment. From this perspective, levels were just beginning to appreciate. Earth was not randomly chosen for seeding. It was carefully planned and monitored as part of a galaxy-spanning initiative to preserve and disseminate intelligence throughout the universe. The mathematical perfection of our planet's orbit, the presence of a big stabilizing moon, and the ideal atmospheric composition for complex life were not coincidental. They were the product of rigorous planetary engineering. This scenario exemplifies the Fermi paradox perfectly. We don't detect alien civilizations since they aren't distinct from us. We are their descendants, carrying on their genetic lineage while slowly redeveloping their technical capabilities. Every human being is a living tribute to civilizations that lived billions of years before our solar system originated. The silence we hear is not empty, but success. The ancient seeding operation was so successful that its products, including humans, developed their own technology and began seeking for the civilizations that created them. We search for our forefathers, unaware that we carry their genetic traces in every cell of our body. Recent advances in genetic analysis may be revealing traces of this heritage, the mathematical patterns hidden in DNA, the unexpected optimization of biological systems for surviving cosmic radiation, and the universality of genetic codes all point to purposeful design rather than random evolution. If the understanding is correct, and humanity's place in the universe is significantly greater than we previously anticipated, we are not random results of terrestrial evolution, but rather heirs to a cosmic civilization that sacrificed itself to ensure that intellect persisted throughout the universe. However, if ancient civilizations purposefully seeded worlds such as Earth, the next question is whether this included direct action rather than passive genetic dispersal. In 1973, Francis Crick, who had earned the Nobel Prize for discovering the structure of DNA, made a surprising statement that stunned the scientific community. Life on Earth was too sophisticated to evolve organically in the time allowed. Instead, he suggested that intelligent extraterrestrial civilizations intentionally transferred genetic material to our planet via unmanned spacecraft built particularly to seed suitable worlds with life. This wasn't just wild speculation from a fringe thinker. Crick had spent decades studying the intricate mechanism of cellular biology, and he understood better than anybody else how incredibly complex even the most basic biological systems are. His controlled panspermia theory arose from a cold mathematical examination of what evolution could and could not achieve in Earth's brief history. The data that concerned Crick are considerably more concerning. Today, a bacterial cell includes approximately 4 million neatly ordered molecular pieces. Mathematicians struggle to express the chance that these components will spontaneously organize into a working organism. It's like a cyclone passing through a junkyard and unintentionally building a working jumbo airplane, only the odds are considerably worse, thanks to purposeful panspermia. Solves the probability problem elegantly. Instead of expecting life to arise from scratch on every planet, it proposes that intelligence, once achieved, has responsibility for spreading throughout the cosmos. Advanced civilizations do not survive alone by traveling to new worlds. They preserve their biological legacy by purposefully planting possibly livable planets. Modern technology makes rapid scenarios more feasible. We now know how to create microscopic devices capable of self-replication and error correction. We understand how to encode large amounts of information in DNA sequences. We have identified the genetic changes that might enable species to survive extended space travel. If we can foresee these technologies after only decades of molecular biology study, consider what civilizations with millions of years of growth could do through guided panspermia. Solved various mysteries of Earth's biological history. The global genetic code shared by all living things on our planet makes perfect sense. As a design system designed for reliability and mistake correction, the rapid development of complex cellular machinery in the fossil record makes sense if it was engineered. Rather than evolving, recent discoveries suggest that such seeding missions may have occurred. The Nebula object, which traveled through our solar system in 2017, showed features that some scientists interpreted as artificial rather than natural. Its unique, elongated shape, sudden acceleration, and trajectory hinted that it was a probe from another star system. If guided panspermia exists, the Earth's whole biosphere marks the effective completion of an ancient terraforming endeavor. Every forest, every marine habitat, every organism that has ever existed has the genetic memory of civilizations that died billions of years before our kid was born. This approach radically alters how we think about ourselves.